This is part 2 of chapter 11.3. We have one more example to do just so you can get some more practice. So here is the situation. Um, Time to earn a bachelor's degree. A researcher with the Department of Education followed a cohort of students from 1992, monitoring the progress the students made toward completing a bachelor's degree. Um, One aspect of the research was to determine whether students who first attended community college immediately those who attended community college took longer to get a bachelor's degree than those who went to the four-year institution. So here's the sample. We here have 268 community college students compared to 1145 directly going to university. And the time to graduate took 5.43 and 4.43. Here are the standard deviations. And so looking at this here, it looks like it takes community college students longer to transfer, but as we now know that a sample is not enough to make a conclusion, one sample, we need to run some tests, formal tests, confidence intervals, other ways to kind of verify it. So here we're going to run a hypothesis test. So let's go ahead and take a look at the questions that were being asked and see how we can address those. So let's go ahead and the first question being asked, what is the response variable of this study and what is the explanatory? Again, before I do it, you should be thinking about what that is. And so in this case, the explanatory and response variables, and this is for part A, the response variable is the time to graduate, and the explanatory variable is the community college or not, right? The college, it's really the college type. That is, does that explain time to graduate? That's part A. Part B, what can we answer there? Explain why the study can be analyzed using the methods of this section. Well, we have, I think one way to think about it, we have independent groups here, meaning that they come from two, they're not dependent. One does not depend upon the other one. These are different students. And so for sure, because we have independent groups, we can we can also conclude here the RV is quantitative, which is one of the characteristics. The response variable is quantitative, and then we can assume it comes from a simple random sample. The sample size is large, right? N is large, but it's not too large. So we have those reasons. Part C, does the evidence suggest that community and college students take longer to obtain a degree? Use a alpha level. So let's go ahead and let's conduct the test here. So we're testing, does community college transfer students take longer? So what we care about is we're thinking that the mean for community college is bigger than the mean for four-year students, right? That it takes them longer. So what would our hypothesis be? I'm going to zoom in a little bit. Our hypothesis is going to be, our null hypothesis would be that the mean of the first group is equal to the mean of the second group, and this would be the community college group, and this is the four-year group. This is a CC. The alternative is that the mean of the community college group is bigger than the mean of the four-year group. I think we said use a 0.01 alpha level significance to do that. This would be a right tail test. And so we go ahead and calculate the test statistics. We would need to go ahead and then run the test here. In order to do that, we need to know the values, we need those values there. So we're going to have to enter those into StatCrunch. And so let's go to StatCrunch. T-stats 2 sample with summary this time, not data. The sample mean for the first group was 5.43, standard deviation 1.162, sample size was 268, sample mean 4.43, standard deviation 1.015, sample size 1145. We're going to do a hypothesis test. The first one is bigger than the second one. Compute. We get a test statistic of 12.9. Wow, 12.98. 12.98, and the p-value is really small. So we get 12.98. Your t is 12.98. Your p-value is very small. So small, it just says less than 0.0. What are we going to do in this case? Because the p-value is low, lower than alpha, we reject h naught. Since 0.001 is smaller than 0.01, this is smaller than that one. What's our conclusion? We have there is sufficient evidence to support the claim that community college students take longer to graduate. And so that's our conclusion there, and that's running hypothesis tests on independent samples. We could also do that via a confidence interval, and so the next question was construct a 95% confidence interval that compares the community college to the four-year students. And so then with that there, we would then do the same. We would do the same thing here from, but again, this time we can choose the confidence. It doesn't have to match up to the alpha. We would like to, but it doesn't always have to. We can choose a higher level of confidence if we want, or a lower level of confidence. We ran at alpha 0.01 with the hypothesis test. Here it's just saying construct a 95% confidence interval. And so it looks like we get 0.85 with 115, 0.85. And so in this case here, running a 95%, we get 0.85 and 1.15. So the probability, I'm sorry, there's 95% confidence that the community college students take 0.85 to 1.5 years longer to graduate. What does this mean again? We're going to reject h naught since the confidence interval does not contain 0. 0 is not in between those two numbers, so which means that these are not equal to each other. The differences are not equal to 0. And so there is a difference between community college students and four-year student. And in this case, the point estimate, which is right in the middle between those, would be 1.0, and then your margin of error is 0.15. And so that's what we would have. Let's see, did we answer everything? Part E, do the results of C and D imply the community college causes you to take extra time to earn a bachelor's degree? Cite some reasons you think this might contribute. And so what's our conclusion on this case? What are you thinking about? Maybe you already had that since you're community college students. You had some idea already. And so again, because of our level of confidence, we can what can we conclude there? We run the test, we did a confidence interval. Do the results C and D imply that community college causes you to take extra time that community college causes you to take extra time? I would say no, the results do not imply that community college causes you to take extra time. This is just observational data. Community college students may be working more hours, which does not allow them to take classes. So it doesn't mean that community college causes them to take longer. It could be the factors around why you're in community college, why it takes you longer. So community college is not necessarily the reason why. It could be the factors related to that. And that's it.